In this lecture, we'll look at how to install some applications. We'll look at how to install SSH server. We'll look at what SSH is. We'll also install a couple of other services that you should not run. But at least it'll show you how to go about the installation process and how to network your computers together in a host-only based networking situation. We'll install FTP, which you probably already used, but we'll also install Telnet. And I think I've already talked to you about this before, but when you log in to an FTP server or a Telnet server, you're sending your credentials in the clear. That is, there's no encryption involved. So if somebody's listening in on that network layer, is that they're able to capture that information, and then they know your username and password. Odds are, at least for a lot of people, they've used that username and password for other services, which could be a lot more important. So we'll always want to use SSH when we're connecting to another computer. That's the safe thing to do. Since we'll be installing some applications from the internet, we'll need to access the Ubuntu repository. And so we need to make sure that our settings are correct if we're using VMware. Notice it says network address translation. We're going to share the host's IP address. It should be okay. We want to type ifconfig. Make sure that looks like the shared address. This is a 10.130.3.60, so I am sharing my Windows 7 box's address. Hit clear. And we want to install 3 different services. We want to install OpenSSH, which I've discussed previously. And we want to install FTP, File Transfer Protocol daemon, as well as Telnet. Once again, typically we don't want to allow access over FTP or Telnet because they send your credentials in the clear. You can always use some form of a secure copy or secure shell to get at those files on another server. No intelligent systems administrator running his root will ever SSH into another box. We'll never connect to another box without using SSH. So we want to install OpenSSH-server, which will allow us to communicate over an encrypted network connection to any other server that's running SSH, secure shell. We also want to install Telnet D and something called VS FTPD, Victor Sam FTPD. Remember, in real life scenarios, we don't want to run Telnet or FTP because they send all your credentials in the clear. And so we can always connect to another computer as long as it's running SSH. And I don't know of any Linux boxes, especially servers, that do not have SSH installed. Okay, we know we have our network connection. We can go ahead and hit enter. And apparently, maybe we've already got Telnet installed. We've got some upgrades here, and FTPD will be installed. Enter, and if this is going to take too long, I'll pause the video. It's going pretty quickly. We notice that the script automatically starts and stops the SSH daemon. So it stops the old one and it restarts the new version with a new configuration file. Notice that we've added a user FTP to group FTP, and the FTP daemon has started and is running. Now, if we want to make sure that all of that worked correctly, we can run the command netstat, which shows you your services running, and -tpan. Without getting too much into it, let's just say that's going to show you those arguments, what services you have running. So we have got 3 services running. We've got a service on 21, 22, and 23. 21 is going to be our FTP daemon. And notice that it's in a state of listening. SSH runs over port 22 in a state listening. And Telnet runs on port 23. It's in a state listening. So we're all good. So that was very simple to do. And now what we can do is we can go over to our another box over here. Let's make this so you can see it. Let's go back over here because I can't remember what the IP address. Let me write that down. Oh, in fact, what we want to do is let's go ahead and put this on a host-only based network back where it was. Let's go here to settings. Let's put this on VMnet 5, which is host only. And if we do an ifconfig again, we're going to see that it hasn't changed. It doesn't automatically do that in server. So what we need to do is to initiate two commands in ifdown eth0. Notice up here that that's the name of our network card. ifdown eth0. And ifdown is a script that connects to ifconfig and brings down your network. And so you see that the DHCP has released the shared internet address. So if we do an ifconfig here, we'll see we no longer have an eth0. We've only got our loopback address. Now we need to issue ifup. So bring up eth0. Now it's going to reach out to the DHCP server, and the DHCP server will dole out a private IP address because we've already stipulated that in our settings up here under VMnet 5. And notice now we've got .14.133. So we've got our host-only based network, and notice that it also stopped and restarted our SSH server. If we go over here, I'm not sure what. Okay, obviously this is not on the same subnet, so we need to go up here and change this so that we're also on VMnet 5. And because we're running the desktop server, there is a program called Network Manager which should automatically note the change in the network that I just stipulated, and should, and it, of course it's not going to do it because I'm recording this, it should note that change, and it should give you a new IP address, and it didn't do it. So we need to do the same thing here. ifdown eth0 sudo ifup eth0. And we see that we have a new binding to eth0.14.129. Okay, so we're clear. And now what we can do is that we can do a few things. We can, in fact, what I would like to do though is to show you something I don't believe I've shown in this class, is that just so you understand that I'm not kidding when I say that the credentials with Telnet and FTP are sent in the clear. What we're going to do is we're going to do, and I don't want you to do this, so I'm going to hide what I'm doing, but what I'm actually going to be doing is capturing network packets, and then we'll analyze them, and I'll show you how this information is sent in the clear, whereas SSH is encrypted. So hold on a second. I don't want to get into this because I don't want you doing this now. You will learn this in a couple of other classes. So right now we just need to concentrate on how to work with Linux. So hold on. Okay, so over here I am capturing some network packets, and what we're going to do now is that we're going to connect via Telnet and FTP and SSH to the other server .133, and then we'll look at those packet captures. And so we want to Telnet, and I've got the same account on each, the username PC, So I can telnet, whoops, .14.133. And you see that obviously the service is running on .133 because we're getting the login here, and PC, and my email address, my password, and we're logged in. And so if we go over here, notice those files that are listed here. If we switch back here quickly, those are the same files. So we're logged in. Let's get out of there. Type exit. You're logged out. The connection is closed by the foreign host. And let's type clear. And now let's log in to FTP. And so we're going to type FTP 192.168.14.133. Notice that we're getting the login information for .133. Notice that the default here is PC because that's what I'm logged in on the local machine. We'll go ahead and type that. Local password. And do an ls, and we see that we do have a connection. And those are the files that were in the home directory of the computer. So that worked. And we can type buy. There we go. And we're going to do one last thing. We're going to SSH in to the other computer. Now, what I explained this last time is that SSH uses public-private key encryption. So the host is offering its public key, and it has a fingerprint, which is essentially a digital fingerprint that's unique to the exact contents of that file. So if we know, for example, by calling the system administrator and saying, could you tell me what the RSA key fingerprint is of your SSH server, and they reel off this number, that means that we are connecting to the right machine and no one's listening in. Yes, so what this is going to do is just going to save this on our local computer, so it won't ask us that anymore. And we're logged in over an encrypted channel. And there are the files. Now what I need to do is to stop my packet capture. Let me do that, and then we'll take a look at it. And so there were 307 packets that were received by the filter. 0 packets dropped. So we know all the network activity was captured because no network packets were dropped. Now what we need to do is open this up in this packet analyzer called Wireshark, and we'll take a look at the connections for those services. So if it's installed, do you remember what command we used? Wireshark, is that installed? Yes, it is installed. So we can type Wireshark. So this is a protocol analyzer or a packet analyzer. And what it does is it takes those binary packets and parses them out into a human readable form. So we can type open, we can go to my home directory, and I save this file. It's called pcap. There we go. So this don't let this overwhelm you right here. We will just pop down here and find the appropriate packets. You see here that the packet 37, this tells the packet number and the sequences that were captured, the time, the source IP address, and the destination. Recall that our source was .129, the local machine. The remote destination was 133. It used client-side port 54658, which is randomly selected by the operating system. And we're connecting to Telnet. And if you've had your networking, you see that this is a three-way handshake. SYN, SYNAC, and then ACK. So that means we're connected. So if we go in here and follow this, what Wireshark does is it assembles everything so we can read it. Okay, oh my goodness, look what happened. we see that the Ubuntu login, notice this says ppcc. You'll see that any time that you use Telnet is that some characters are repeated. But we see that was my login, and there's my password. That's kind of scary, right? Okay. Okay, we'll clear this. Now let's go down and find FTP. Notice this is the other parts of the session where we had Telnet data coming back when we were doing the list directory. We don't need to take a look at that. And we'll just scroll on down here. And you see, if you've taken your networking, you see that these 4 packets are closing the connection between the local machine and the destination machine. And if we scroll down here to packet 148, we see that we're trying to connect to FTP on the destination machine, SYN, SYNAC, and ACK. And so we've got a connection here. Want to right click part of that. Once again, look at that, PC, and the password was foobar. It lists the command that I issued, list ls-al. So you say big deal. It really doesn't matter because I don't care if somebody has my password. Any type of file that you're copying, which could be something important, intellectual property for a company or anything, is readable and can be captured and can be stolen. And the thing is, what happens when you, let's say when you steal a car? Well, somebody goes out, they see their car's gone. What happens when you steal somebody's digital information? They don't know it. And so it's always important that you use a secure form of communications anytime you're sending and receiving important information. So we can scroll on down. Need to clear this. And we'll get down here to our SSH session. Okay, packet 214. So from the source to the destination, SYN, SYNAC, and ACK, the SSH port, which we know is 22. Let's follow this. Anything in there interesting? No. You notice that there is some human readable information, SSH 2.0, Open SSH Server, and so on, SSH RSA. What this is doing is it's negotiating the type of encryption that's going to be used between the source and the destination address. That is, they have to speak the same language. And so if we move down here, what we'll see is, notice here this says there's a key exchange. Is that there's a public key exchange, so that once these keys are exchanged, everything after that, notice this is using something called the Diffie-Hellman key exchange right here. Everything else after that is encrypted packet request. And so let's go here and see if we can see anything. No. Going down here. No, everything is encrypted after that. And so any of the information sent to or received from the destination computer was encrypted. And it's encrypted with high-grade encryption, and it would be difficult, if not impossible, to break. Maybe the NSA could break it, and if they were able to, they wouldn't tell you anyway. But you see, it's important to use secure communications. You should know why you should do it. There's no reason to use Telnet or FTP. It's much smarter and just as easy to use SSH.